Good morning, this is Dr. Turner with Integrated Math 2. Today we're going to be looking at 1.5, solving equations with exponents. While later in the year we're going to be looking at a more efficient way to do this. For right now we're just kind of falling back on our rules of exponents and what we looked at in 1.4 and 1.3. So this is what this assignment is going to look like. It's going to start out, you'll have a few questions on your assignment that are going to step back to a little bit to 1.4 and 1.3. So you might have something like this x equals, let's say, 4 to the 3/2 power. So remember, when you have an integer raised to a fractional exponent, you are going to separate those. From here, you can evaluate the square root or the power first. So if I did the power first, 4 cubed is 64, and the square root of 64 is 8. Right? That's going to be true for any of these. So if I have x equals 216 to the 2/3, now, again, 216, that is cube root and squared. Here, let's say I choose to do the power or the root first, cube root of 216. That gives me 6, and 6 squared gives me 36. Okay. So those are all review. There's a couple of those sprinkled in here, but the rest of the assignment is going to look something like this. So I have 5 to the x equals, let's say, 125. Now the goal is that if the bases are the same, this is something that I can evaluate. And so to solve a problem like this, I'm going to rewrite 125 in terms of a base 5. So you would go through and say, okay, 5 times 5 times 5 is 125. That means this is 5 cubed. And the only way these two would be equal is if x equals 3. So a little bit of review with exponents in addition to a little bit of review with solving a 1- and 2-step equation, even though this is an exponential expression. Let's try another one. Let's say I had something like 4x plus 1 equals 5. Subtract 1 on both sides to get the exponential term by itself. 4 to the x equals, 4 is already base x, or base 4 rather. So that means I have an exponent of 1, which means x equals 1. I could have something else, 2x minus 7 equals 25. Add 7 on both sides, I get 2x equals 32. Rewrite 32 as a power of 2, so 2, 4, 8, 16, 32. That's 2 to the 5th power, which means x equals 5. I could give you something that has more than one step. Let's say I have 3 to the x divided by 2 minus 5 equals, let's go with, you know what, let's try that. Let's change this to a 6 to the x over 2 minus 5 equals, and I'm going to make that 13. So your first step, you would add 5 on both sides. To get the exponential term by itself, you would multiply both sides by 2. Rewrite 36 as base 6, so that's 6 squared. And your answer is x equals 2. Keep in mind that you can have fractions, you can have decimals involved here, especially if we're talking about negative exponents. So for instance, let's say I have 2 to the x minus, and I'm going to do 1/8 equals 1/8, for instance. So I would add 1/8 on both sides, and maybe I need scratch work if this has been a while. When we add fractions that have the same denominator, we add the numerators and then simplify. So we have 2 to the x equals 1/4. Well, I can definitely rewrite 4 as 2 squared, but this 2 squared is in the denominator. So this goes back to our rules of exponents that we covered in 1.2. We want to rewrite this as 2 to the negative 2, which means x equals -2. So that's pretty much it. You just have a few examples that are asking you to solve this. Again, later on in the semester, we're going to be looking at what are known as logarithms that are going to help us do this a little more efficiently than just trying to guess. But that's all for today, guys. Have a good day. and I'll talk to you soon. Bye.